Hello students, today we are going to discuss about automatic indexing. So we have seen different kinds of indexing terminologies and how we are going to do the index. In this session you are going to know about automatic indexing. So what is meant by automatic indexing? By the name itself we can tell that automatically the data will be indexed. So how the data will be indexed and what are the selection process and how we are going to do this. So we have to see. Now, so this is an example where we are taking total document indexing. So in this our complete total document will be indexed and it requires only few seconds. By the name itself automatic indexing will take only few seconds in order to complete, and it will basically based on the processor and whatever the complexity of the algorithm you are going to use in order to generate the indexing. Suppose if I am using neural network or if I am using ANN, CNN or general Bayesian algorithms for your indexing. Then there will be complexity difference between these two, complexity difference between these two and complexity difference between these two. So the basic thing depends on time complexity is what type of algorithm you are using for indexing part, and another is what type of processor. And the third point is what is the advantage. Okay, so as we are involving the system to do the index part, the consistency will be more in the selection process. For example, I am indexing about the word starting with good. So we have seen what are the 1 gram, n gram, whatever it may be. So how this particular term will be indexed. Okay, so after good you may have morning or you can add evening or anything. So this have to be indexed as one, whatever the word you are using and whatever the index terms we are going to add. So this will be done according to the algorithm. And this particular indexing results in automated indexing with two things. Remember, weighted and unweighted. So automatic indexing consists of two parts. Yeah. So remember, you have weighted indexing part and unweighted. So what is meant by weighted and unweighted? We'll see in the next slide. So first one is unweighted indexing. So what is unweighted indexes? By the name itself, it will not give any weightage for the time. So if I am taking one word or a term, I will not assign any weights. Okay, and this will be always stored in a location. Word location will be stored in a searchable data structure. So what I'll do, simply understand that whatever the words you have, hello, okay, good or bad. So if you observe this, in this you don't have any link or any index term. So I term is not there. Directly you store in this particular data structure and with the help of the searchable data structure. Remember this point. Searchable means you can search all the elements in the given data structure. So second one is your weighted indexing system. It will have some value on the index term associated with the concept in the document. Okay. For example, same I am taking hello, bye or good, whatever it may be. So I will always create one index for this where I have a term I, J, K, which will be linked to your document. So this available data is in the document. So within the concept of the document. So unweighted only will have the searchable terms and this will have the weightage of your document. Or you can also write the frequency of the occurrences. I remember we have discussed about this weightage, frequency of occurrences. If I am taking one document over here, yeah. So you are taking one document over here. How many times the good is repeated? So if I am writing good, the frequency of the good is 3. F equal to 3. So similarly what you do? If I am taking the frequency, this is my index weighted document. I'll write your frequencies. This is your 2. Okay. I'll take bad. I have only 0. Suppose if I have one more letter called X frequency is 1. So this is the weighted indexing. Okay, same. As I said, your values will be normalized between 0 and 1, and the results are represented in the user in the order to rank the value from the highest number to lowest. Suppose what I do, I have the, imagine that we have x, y, z as terms. The frequency of x is 3, 2, 0. So always you have to order in the highest number to the lowest number. Okay. So indexing will be by terms. As I said, x is a term, y is a term, and z is a term, and it will be original item. So because I should not, if your document is there, here I don't have x, but I am mapping over here. So this is not original term. So always remember, whatever the terms are present in your document have to be indexed. And in order to create automatic indexing, we have two major techniques. One is statistical and another is natural language. So what is meant by statistical and what is meant by natural language automatic indexing? Okay. So coming to the statistical, you can use vector models and probabilistic models with a special case like a Bayesian model. So remember, in the statistical we have two models. One is vector model, another is probabilistic, right? Probabilistic. So what I'll do is, as I state, we are writing the frequency in the form of model. So I'll create here one vector. So you'll create one x, y, z or a. So you create one vector and you will calculate all the frequencies of this. How you are going to calculate the frequency? I can use Bayesian model. So this algorithm depends on your whatever the model you are going to use. And this weightage calculation have to be frequency of the occurrences, suppose. So in the two models, you are going to store in the probabilistic and vector model, but both you have to store the frequencies. Okay. So what is a common point? In probabilistic or vector model, you are going to store the frequencies, but the thing here is what type of algorithm we are using. In the probabilistic, you will go for Bayesian for calculating the frequencies, because you have to check for the uncertainty also. Now next one is your natural. Natural language is also some of the statistical information is stored, but so this will use parsing. Okay. So what we have done in that, we have used Bayesian model. Okay. Here we have to use the parsing. So in vector or probabilistic model, you have to use the calculate the frequencies, but in case of Bayesian, we have to go for the parsing thing. Here also you can emphasize on the weights and how you are going to store the data in the form of vectors. So what is the basic difference between both? First one is we use the Bayesian network, second one is parsing. End of the day, you are storing in the vectors, and please concentrate on the frequency. So this is more important. Okay. Yeah. So exactly how we are going to use Bayesian approach. Okay. So based on evidence, reasoning, drawing conclusion from, see, if you see that P of A by P of, I'm just telling. So what is the probability of occurrence of A on condition, some condition you are mentioning. So this Bayesian approach always depends upon the conclusion from the given evidence. It can be applied as a part of the indexing term weighting, or you can also use for retrieval process, or in order to calculate the relationship between two terms, and also you can write a query. Okay. So the Bayesian approach will be very comfortable for all these applications, and the graphical representation of this can be done. I'll show you 1 second. So this is a two-level Bayesian network. If you observe, I have C. C is the concept. So if I'm taking some concept, good. Okay, don't take it as good. One document is there, some letters are there. F represents, so if I'm take, okay, good, bad, hello. So good will be what is the terms present in the good if I am taking terms as good morning. So these are the terms. So it will be F11, it will be F12. Okay. So coming to the second one, bad, if I have only one value like this is a representation of a two-level Bayesian networks. So where you will have the document, all the letters will be there, and again this will have C11, again this will have C12, again this will have C13. Okay. If again go for some other document, again I have to generate the tree. So this is a two-level Bayesian network. So what we are discussing, okay. So you can mention the graphical representation is over, and what are the probabilistic dependencies. Suppose if I am taking this one, what is the dependency of this term on over this particular C value, okay. So these are the automatic indexing terminologies. So this is a graphical representation. So one more approach is about DR link. So document retrieval through linguistic knowledge. So by the name itself, it will be based on whatever the set of terms you are using and how many terms will be have to be indexed. It is also known as latent semantic index, and it was developed by HNC. So here I don't calculate any frequencies or weightage directly. According to the retrieval, some knowledge about that terminologies we have to retrieve. So next one, it uses neural networks in order to strengthen the system. Okay, so in order to strengthen fast your system, always identify the relationship between the synonyms, and you will use two neural networks for generating the stem text context vectors and another to perform query. And the next one is multimedia indexing. It will always based on your videos and images, and it will always look up the position and time of the value. So this is multimedia indexing. Okay, so these are the different types of automatic indexing in your retrieval system. Okay, so finally remember that this is always works on your synonyms and found the relationship between given values. Thank you.